Ready-Made Maths YouTube training. Teacher and teaching assistant training, readiness for mastery in EYFS. This is part 2 of day 4, number party. In part 1, we were in the Ready-Made Maths classroom looking at loads and loads of ways to show, talk about, apply and discuss the number 6 and other numbers that come within the number 6. In this particular part, this is the follow-up session, which is more of a PowerPoint presentation to take you through the whole ethos behind number party, which is subitising numbers using small amounts and developing the skill of subitising, and also looking at very simple images for the numbers 6 and 8, continuing the work that we've been looking at all week. I'm also going to show you one of my favourite websites of all time, which I think everybody should have a look at, and we're going to conclude just by having a little sing-song to end the week. Hope you enjoy it, and please, if you haven't seen video part 1, please have a look at that first, as these two videos are designed to complement each other. I just thought I'd start this session just by showing you probably my favourite mathematics television website ever. This is Number Blocks by the BBC. I don't think I could recommend this particular website highly enough. It is absolutely superb. Just looking at the screen in front of you, what do you notice about numbers? Well, straight away here, I've got a number 6, which is being displayed in a couple of different ways. Over here, I've got the actual characters 1 to 10, and you can see certain characters are in a straight line, 1, 2, 3, 5, and 7. I wonder why that is. You've got other characters that are squares, number 4 and number 9, and you've got 3 rectangular characters, number 6, number 8, and number 10. There's got to be a reason behind that, and that's explored really effectively in the Number Blocks episodes. Here you can see that number 10 isn't always a 5x2 array or a tens frame. I love the fact that number 10 is a tens frame, because we're going to be doing masses of stuff on tens frames in these sessions, but he can also be a straight line as well. As can number 8, as can number 6, as can number 4, and as can number 9. There's just other ways that they can be represented. Over here we see number 1 block. Number 1 has obviously got 1 block. We can see number 2 has got 2 blocks. Number 3 has got 3 blocks. And I love this. Look at 0. I wondered how they do the 0 character. And the 0 character is basically a mouth, but with no body, because it's actually, not got an amount, but it's still an actual number. And last but not least, love this here. Now, this is from the actual Number Blocks Twitter page. Here's number 4 in his basic image, which is the 2x2 square. But look at this. What can number 4 look like with actual blocks if he's rearranged in different ways? There's the obvious there's the obvious straight line, there's the square, but then there's a range of different other ways that we can set up and look at the number 4. So I'm just going to show you a very, very brief clip from Number Blocks. This is the 10 song. This is where number 1 is wondering why number block 10 has got a number 1 on top. Have a quick look at that, just so you got a little brief look. Definitely let your children watch Number Blocks if you get them back to school, or if you want them something to do at home while they're at home, while all this is going on. If you want them to actually have a look at something that they're going to really enjoy, there's a whole series of CBeebies Number Blocks episodes that are freely available on the internet. Let them have a look, and hopefully by the time they come back, they'll already be excited by these characters. We're now going to watch the 10 song.
1 bigger. You're 1 bigger.
Why do you have a 1 on top?
If you're wondering why there's a 1 on top, you'll know the answer when you realise I'm 1 big block, I'm 1 big perfect 10. I'm a 10 block, I'm a 10 block. You might think we're different, think again. We're more alike than you suppose. You're 1 1 and I'm 10 ones, which means I'm 1 10. 1 2 3 4 5 6 7 8 9 10. 2 is made of 2 blocks.
I'll always be your friend.
3 will entertain you.
On that you can depend.
I'm 2 ones.
And I'm 3 ones.
And I'm 10 ones, which means I'm 110. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
As you can see, really child friendly. There's always little songs that go in there. And what I love about that is that reference of 10 ones, 110, 10 ones, 110, which is something I do an awful lot on training. Let the children see, yes, it's worth 110, and that 10 is made up of 10 ones. And that needs to be done with all the other numbers as well. There are many other really fantastic episodes on the number blocks. So as I say, get children to have a look at it while they've got the chance. If they were to watch maybe 1 or 2 episodes a day for the next few weeks, they're going to really be able to explore that power of numbers with really interesting and dynamic characters that are really child friendly. And you'll find them just kind of staring at the screen and really getting captured by the power of small numbers. I'd just like to start this bit of the training, and kind of part 2 of today's training, by looking at a simple little activity called Subliminal Subitising. We're almost kind of going back a little bit to the sort of activities that we could do just to develop a sense of early number and seeing number within number, which we looked at on the table earlier. Again, this activity I'm mentioning now is being done with counters, but can definitely be done with any resource really that can be distributed on the floor or on the table. I want to imagine now we're just throwing some single-sided counters onto a table, and then we look at what do we actually notice about them and how we describe the arrangement. Let's first of all, though, just define what subitising actually is. Subitising is actually a technical term in psychology. We use it a lot in early years mathematics, but it's actually a technical term in psychology, which means, in a very posh language, to apprehend directly the number of dots in an unstructured stimulus display without counting them. The limit of this process is about 7 or 8 dots. I think the key word here is unstructured stimulus display. Apprehend directly, i.e. I know how many there are just by looking at them without actually counting. The human brain can only really, as it says, process about 7 or 8. What's really interesting is most people's brains will only really apprehend 5, possibly 6, unless they're in a very simple arrangement that is easily recognisable. Obviously, once they are arranged and structured, numbers like 9 in a 3x3 array or 10 in a tens frame image can be recognised straight away. But 10 kind of randomly displayed or unstructured is not something that will be recognised easily. What I'm going to do now, I'm going to show you the first slide, have a quick look at it, and just what do you see? Just say what you see when it first comes on the screen. Now, I'm sure very quickly we can see that's the number 5. Again, if that was just shown to you for half a second, and then you were asked to say what you see, you'd definitely still say 5, but did you actually see 5? Most people don't see 5. They may see a line of 3 going across the top, and then 2 underneath. That's obviously 5, but it's seen as a 3 and 2. Other people, their initial reaction is 3 down the middle, 1 on that side, and 1 on that side. Other people, they see a 2 here, a 2 here, and a 1 down here. Other people see a 2 here, a 2 here, and a 1 up here. And others see a 4 and a 1. And that is the point. There's so much amazing mathematics just in 5 counters, kind of distributed on a table in a random arrangement. There's masses of stuff that can be talked about of all the different arrangements we can see. As the numbers get slightly bigger, again, although some people say this looks like a giraffe or a pram, a little bit of psychology there, as a number, what do you see? Very unlikely you'll go 7, but within about a second you might go 7 because you've seen something about the numbers. You've been able to pull out smaller numbers from the larger number. You might have seen 2, 4, 6, and 1. A lot of people see that. You might have seen the 4 kind of in the curve, and then 3 down here in the kind of triangle. You might have seen 2 here, 3 here, and 2 up there. And there's many other things that you might have seen. This is a brilliant activity just to do with counters, just to talk about. It's a great activity with pictures of anything that you can put on a screen that children can look at, you can throw on the floor the children can look at. Just say what you see. How many can you see and how do you know without actually counting them individually? What little small subsections of numbers do you notice? Again, that's a much larger one. With this one, I'm actually going to show you some examples that children have told me in the past from actually showing them this particular image. First of all, though, you put this image in your head. There are 9 counters. How do you know? And imagine with this one, you're certainly not going to be saying 1 less than 10 because it's not in a tens frame. You might say 5 and 4, but possibly not. You're certainly not seeing a 5 and a 4 in a structured arrangement. What are you actually seeing? I'll show some that children have shown me in the past. First of all, that one, where the top line is left as a 4. It's almost like horizontal line thinking, really. I see 4 on the top line, 2 in the middle, and 3 in the bottom. That one, still 4 in the top line, but this time a triangular 3 and a 2. One of my favourites there, the 2 triangles. The triangle there, which is 3, and some children just get fixated on a triangular pattern. So a 3, and then a straight line 3 at the bottom. My overall favourite was this one, because it's when you see the original image, very few people see that kind of almost circular image in the middle with kind of one on the outside. But when you see it highlighted, it kind of jumps out at you. I can see that there are 5 there. Oops, other children would include that one as well to make 6. My final image is this one, which is almost a skewed dice image. A dice image of 5, a dice image of 3, and a dice image of 1. They all show you 9, but there's so much more high-level mathematics about building up smaller numbers within the bigger numbers. Again, this works just as well at Key Stage 1 in Year 1. It's a really nice activity of both foundation stage, reception in particular, and Year 1, but with other resources and with other pictures, not just with dots on a screen. The double-sided version is definitely moving more into Key Stage 1, but the same sort of thing does occur with a double colour version of this, with double-sided counters. You get so much brilliant mathematical discussion out of the children about the numbers that they see and how they know the overall total. So we've just looked at the number 6. We've seen 6 in so many different ways. We've seen it represented with different visuals and laid out in different arrangements. That's a mastery approach to the number 6. Let's really master number 6. It's not just the numeral. It's not just 1, 2, 3, 4, 5, 6 of whatever we're counting set out in a straight line. It's a range of different images that all tell you something different. So you're building up a real picture of what 6 is all about. Now, in different places of the world, the tens frame is very, very popular in Singapore and the Far East. The Slavonic abacus is extremely popular in Eastern Europe. And Numicon, again, is very, very widely used resource in the UK. They all give slightly different variations of numbers. And then they develop into 12, 15, 17, etc. In our first lesson this week on arrangements, we definitely saw that. What we're doing today is looking at it in even more detail. So could we say to children, show me 6? What might they come up with? What images, if they have just 6 counters of the same colour this time, 6 counters of the same colour, 6 teddies, 6 beads, 6 jewels, 6 sheep, whatever they've got in front of them, show me 6. Let's just see how they possibly could lay it out. And here are some standard arrangements that are often given by children in early years and other ones that are a little bit more advanced. Just pause the video for a second, have a look at those images, and just tell yourself, what does each of those images say to me about the number 6? And secondly, which of those are most popular do you feel with children in the early years when they're asked to show you 6? And which do you think are more popular with adults when they're asked to show you 6? Just right off the top of the head with no training, show me 6 counters, what would you come up with? Let's have a quick look. What you tend to find in the early years, in particular in reception, is when children are asked to give you 6 counters or show you 6 counters, the most popular one is a straight line across the top. The second most popular tends to be the random one, the yellow one there, where the children basically just count the 6 counters out and just put them randomly on the table rather than in a straight line. There are other images within there. There's a 3 here and a 3 here. There's 3 2s. The children haven't counted them that way. They just counted 6 straight onto the table. As you said, there are other images that are contained within that. The third most popular one definitely tends to be the other straight line where the children count up from bottom to top. Having said that, usually by the time the children are in reception and they've got one-to-one correspondence sorted, The predominant way they tend to count usually is the 6 going left to right, rather than the 6 going upwards. Very different with adults. The most popular one by a long way is the 3x2 array. Adults tend to automatically go for that image. It's kind of a more structured image that they tend to prefer. The second most popular is the 8, 6 in a straight line, and then the other array, which is over here. They tend to be, nearly 100% of adults come up with, 98% will come up with one of those 3 images at the start if they've never had any mathematics training. The other images are far less prevalent. This one's just a nice kind of a picture of a double 3 image, but put into almost a circular pattern. The 2 plus 2 plus 2, which is often seen a lot more when the counters are coloured, but not with 6 of the same colour. And this one, which is a lovely image of 6, the 1 plus 2 plus 3, set into a triangle. If we can encourage children to start to use a range of different approaches when showing you a number, then obviously they're going to learn a lot more about that number. The array, which is a 3x2 or a 2x3. The straight line, which is basically one-to-one correspondence. The triangle, which develops eventually into triangular numbers, which is a greater depth overview of what 6 looks like. A very nice visual. The random, or the random style, as we talked about the other day, again, just counting directly onto the table. What I do like about this one, it's, as a counting system, not particularly great, but once the actual counters are on the table, as we looked at with the subliminal subitising, you will see a 2, a 3, and a 1. You can see a 2, a 2, and a 2. You can see a 3 and a 3. So once the counters are on the table, there's actually quite a lot you can explore within that particular image. As a counting system, though, you certainly want to develop from that into something far more structured. The either repeated addition or multiplication, if you want to look at it that way, 2 plus 2 plus 2, or 2 multiplied by 3. I suppose you'd call this the pattern style, where the children are creating their own nice little pattern. That's a kind of 5 plus 1 pattern. But the images that we'd love to see, more often than not, are the 2 that I'm going to show you now. First of all, the 10 frame image that we spent a lot of time looking at over the course of this week, the idea of 5 and a bit, 5 plus 1, is probably the best overall image that the children can see. Secondly, 5 plus 1 set out in a different way, more like the abacus that we looked at, as we called it on Monday, 5 style. If we can move between those 2 elements of 5 style and then develop into all of the others, we're going to get children that have got a really good starting point for their understanding of numbers, and then they've got a lot more depth. Now, when this develops to 8, let's have a look at the same idea. Now, what we can see here, again, are lots of arrangements of 8. I've kept to almost the same images that we've used previously. The 2 types of array, the straight line, the random style, the 2s at the bottom. The only ones that I've altered slightly are the red one here and the green one here. What we see with the red one is a fairly straightforward double 4, in the same way that we see 4 2s over here. And then this one is an absolutely gorgeous image of 8. This is the actual old-fashioned dice style image of 8, or sorry, not dice, the old-fashioned dominoes style image of 8 that there used to be in double 9 dominoes sets, which actually doesn't show double 4, which we're used to seeing, doesn't show 5 plus 3, doesn't show 4 2s. What it actually shows is an array of 9 with 1 missing from the middle. So this really gives the children a bit of depth. It shows them that 8 is actually 1 less than 9 as well. Have a look again at all of these images. Just have a discussion. What's missing, first of all? What can you not see? Which images need to be there? And again, which of these images do you prefer? Some of the things we can see. Well, let's look at them now. Just looking at every single image, how has it changed just by using colours? And it is sometimes a great activity just to leave children with colourful images of whatever they're using to count. The gems, as we looked at earlier on, work really well. The cakes are fantastic for this as well, the cupcakes. Any of those work really, really well. Suddenly we're seeing something other than just 8. The straight line that previously, as you can see, was just a straight line, horizontal or vertical. Look at the 2 straight lines now. One of them is clearly showing a kind of red, blue, red, blue, red, blue, red, blue pattern of 4 plus 4. The other one is definitely showing 2 plus 2 plus 2 plus 2. It's very clear now. Rather than it just being counting things in 1s, you can now count them easily in 2s. Let's have a look at the images that used to be arrays. Well, we've got the array here, and we've got the array here. Again, let's look at the difference. This array is now showing double 4. This array is now showing 2 plus 2 plus 2 plus 2 in a different way to the one on the left, but still showing the same idea. This is showing 4 plus 4, but very different to the straight line above. So again, really powerful images. Let's move on now to the two images at the bottom, the red one and the blue one, which at the moment are 4 plus 4 and 4 twos. There's still 4 plus 4 and 4 twos, but much clearer now. We're just looking at a blue 4 and a red 4. We're looking at 4 different coloured twos. So again, this image, and this image are all totally different images to look at, but they're all showing 4 twos. These three images, again, the line, the array, and the dice pattern or the numicon pattern are all very different, but again, are clearly showing 4 plus 4. The final ones we're going to look at are the random style yellows over here and the 9 minus 1 dominoes pattern. Let's look at those. Suddenly, the dominoes image is less 9 minus 1. It is definitely looking now like a double 4. You can see a 4 there, and you can see a 4 in the corners. It's a little bit like taking this image and putting the two parts together. Obviously, as soon as they're the same colour, it looks like a square, a 3 by 3 square with one missing. And now let's have a look at the random yellow counters. At first glance, when you see the way it's represented, it still looks very, very random. Similar to before, you've got 2 pinks, 2 greens, 2 yellows and 2 blues, but not set out as in a particularly easy to see arrangement. What's interesting about this particular arrangement though, as we looked at earlier, is the way that children can view it when the counters are all the same colour. They can actually see it in different sections. So for example, the children may well see a 3, and 2 1s. Other children may see it as a kind of triangle down here, 3 going down like a dice pattern really, in the middle, and then 2 at the top. Some children are predominantly straight line counters and just see everything in lines. They'll see that supposedly a random arrangement. What they'll see is a 2, a 3 and a 3. Another child may well see a group of 4, because again, that's almost like a dice pattern there. You've almost got a dice 4 and 2 dice 2s. So some children may see that. And you may even get, when you actually see it like that, it's interesting that what jumps out is that number 6, which is that 6 arrangement with the 2 above. So as we talked about in the subitising activity earlier, yes, as a way of counting, this is not a good way to do it. Random style is by far the weakest way of counting and putting things on a table. But once the counters are there and they're represented on the table, then actually asking children in nursery and in reception to look at what they can see in front of them and explain the arrangement and talk about what they see within the arrangement, obviously you get a lot more out of it. Let's just have a look at these again really quickly. We've got 8 counters in a straight line for one-to-one correspondence. We've got the array, which is a repeated addition or multiplication image. And again, we've got the standard repeated addition, 4 lots of 2 or 2 multiplied by 4. We've also got the double, which in this case is arranged in a dice formation. And the one that we've just looked at in quite a bit of depth, we've got the pattern. I want to look at that one. When you look at that picture, what do you see? Let's see some of the ways that this image can be interpreted and why I like this one so much. Let's just show you these. Now looking at those, without seeing the original picture, you can see something very different on each one. And the first one, you may well have seen it as a line of 3, and 2 in the middle. Many children see that, like a letter H really, a large H, 2, 3, so double 3 plus 2. Other children straight away see the 4 going across the middle. That's how they see it. They see a 4 across the middle, and then they see 1 on each corner. So it's either 4 plus 4 or 4 plus 1 plus 1 plus 1 plus 1. And the way I saw it interestingly initially was I saw it as it's almost like 2 people shaking hands. I saw it as a double 4, but in a very different way. I saw 4 on the left and 4 on the right as a kind of symmetrical image. Everyone sees things in different ways, and that's one of the most important things to remember about children and anybody learning mathematics. There is not one way to get an answer. There's lots of ways to see things, there's lots of ways to visualize things, there's lots of ways to get to answers. Let's move away from this idea that maths is a one-answer subject. Maths is very, very creative. There's loads and loads of ways that you can see things. Moving on from that one, there's the dice pack picture, which is again really good to ask the children. Can you show me the number 8 using dice? You can use 2 dice, 3 dice, or 4 dice. And so you can see there the 6 plus 2 and the 5 plus 3. We saw a little bit of that from arrangement style, the song. You can also do a double 4. You can do 4 2s. You can do a double 3 plus 2. You can do a 5, a 3, sorry, 4 and a 3 and a 1. Any of that can be done with the dice, or potentially the dominoes picture as well. There's the Numicon, where I've shown 5 plus 3 again. That 5 plus 3 is a totally different 5 plus 3 to that one. And then again, my two ideal images, the tens frame image and the 5 style image, which need to be the two images that are shown along with Numicon more than any of the others, so the children just get used to seeing them and they become almost second nature. Thought I'd conclude this little activity in looking at different ways to show numbers, to actually show you some of the double 9 dominoes that used to be quite prominent in the 1960s and 1970s. My granddad actually played dominoes with a double 9 set, so when I actually was a 4-year-old, this is not a story I've made up, when I was a 4-year-old in reception, that was my image of 8. Apparently my reception teacher at one point told me to draw to show 8 and to draw 8, and that was the image that I drew. And it was simply because I used to play dominoes with my granddad. So when you said 9 to me, I didn't think of 9 in a straight line. I didn't think of 9 as an abacus or anything like that. I just thought of 9 as a 3x3 array because I was so used to seeing that image of 9. I would have told you that probably that 8 was 1 less than 9, and I would have also told you that 7 was 1 more than 6, or 6 plus 1, because I basically saw the 7 image as a 6 dice with 1 in the middle. It's lovely, you can see again, actually what you can also show at greater depth is the 7 image is the 9 image with 2 taken away. The other exciting thing about dice to me, which often isn't brought out to children, is the difference between the odds and the even numbers. You can't see that from all of these numbers that are here, but the odd dice ones always have a dot in the middle, every single one. That is the number 1 if it was on its own. Then we add another 2 to make the number 3. We put 1 up here and 1 up here for the number 5. And then the number 7, we add 1 there and 1 there. So it's kind of like we're adding the initial image. There's 1, there's 3, there's 5, and then there's 7. Finally, we fill the whole thing in by adding the last 2 to make 9. I love the idea of building that up with children in early years from 1 to 3 to 5 to 7 to 9. The 2 image starts off with 1 there and 1 there. It then becomes the 4 image. The 6 image, we have 1 here and 1 here. And then again, the 8 image, we have 1 here and 1 here. So we can go 2, then there's the 4, then we have 6, and finally we have 8. Obviously today we have been looking mainly at the numbers 6 and 8, but if you do want to kind of wrap this up in a little song, on the Number Fun portal there is a song called Number Party. This is basically allows you to celebrate one number and make it in as many ways as possible. I'm only going to play a brief section of this, but you can see how this one develops. The idea is to ask the children to spend about a minute looking around and finding as much as they can about a given number. In this case, the number 4. Obviously, if we were doing today's activities, I would put the instrumental backing track on and choose the number 6 probably, and ask the children, how many ways can you find 6? Let's have a party for the number 6. But this is Number Party for number 4.
Stop! Gather round, can you hear the party sound? A number's rising up in me, a number's rising up in me, a number's rising up in me. Number 4! Number Party! What can you tell me about this number? Why is it so special? Can you show me what it looks like? 90 seconds, let's go!
And at this point, you do get a 90-second instrumental break where the children are then given that challenge. So run around the room, let's find the number 4.
Wow! Yes!
Let's celebrate number 4.
Just looking at that, I think you've almost got a whole lesson out of that. What do you know about the number 4? Imagine that in nursery or in reception at the start of the year, with some of those images. What do you know about 4? Well, obviously, there's one image there that's a little bit different to the rest, and that's the 2 2-pences, which is they are worth 4, but there's 2 2s, and each of those 2 1-pennies goes with a 2-pence. The others, we've got the straight line image, we've got the numeral, We've got, again, a straight line with cubes. We've got the hand, which is 5 minus 1. And we've got, 4 random footballs, really, that have been laid out. The song does go on to show, obviously, many more images, the 2 plus 1 plus 1 as well. We've got, you look at that. I'd say what you're in now is using an applying land. You've got the 4 as 4 blue and the 4 as 4 yellow, but you've also got 1 plus 3, 2 plus 2, and 3 plus 1. And wouldn't it be lovely if children could use a resource to show you that, whatever it happened to be? Here you've got the similar thing with Numicon. You've got the Numicon 4 piece, which is made up of a 3 plus 1 or a 2 plus 2. It could be 4 1s, it could be a 2 plus 1 plus 1. At the top, you've got a double 2 as well. You can see here, where does the 4 appear? 10 minus 6, 9 minus 5, 8 minus 4, 7 minus 3, 6 minus 2, and 5 minus 1. And at the end of each of those, you do get the number 4 as well. So probably after all the work we've done this week, this is the most powerful visual you can ever see for a song. I could easily spend 20 minutes to half an hour just showing children this video, pausing at different places, looking at the numbers, and maybe just taking little bits of this particular bit. The activity you can see here is what we did yesterday or the day before. How many ways can you show me 3? We actually did when we moved 3 around the egg box. This is the same thing with the number 4. There's positional language, there's direction, there's all sorts. Mathematical language you can develop just from looking at the egg box image. At the end of the activity, then you gather around and let's see what people have found.
Lots to celebrate and see, lots to celebrate and see, lots to celebrate and see. Number 4, number party! Brilliant! Oh, double 2! Oh. Half of 8! Woohoo! Oh, isn't 4 wonderful?
And again, that continues until the end of the song and shows lots of different ways. It's a very good celebratory song, but the main part of this song for me is let's do that for a week. Let's take a number and have a week on a number. Let's not show 4 just as 4 1s, because that's what many people think it is. And it's the same with all the numbers we've looked at today. There's many, many more representations we haven't even looked at, and even the numeral 4 can be written in different ways as well. Let's take this from the from today's activities and from the whole of this week's activities. Let's not think of EYFS as trying to get the children to learn a small amount about a lot of numbers. Let's get them to count to 20 as soon as possible. Let's get them to recognize numbers to 100. Let's get them to make 37 and 48 and 53. I'm not saying there's no value to that, but there's limited value to that in early years. There's a much, much, much stronger sense of number and much more value to asking the children to find a lot about smaller numbers. Thanks so much for watching all of the early years activities that have been presented this week. Hope you found it an interesting group of video sessions, and that you'll be able to use lots of the activities back in school. There will be future early years training videos that will be coming up within the next few weeks, so keep an eye out for those. Obviously, it's also worth checking out the songs from the Number Fun portal, which will give you a lot of additional activities that you'll be able to use in class as well. For the time being, thanks so much for watching. I will be posting next week's programme very, very soon, so you can see the examples of mastery that are coming up. Next week, as I just mentioned, is basically a mastery focus, and we'll be looking at shorter videos that show you how to master key elements of mathematical understanding in Key Stages 1 and 2. But thanks for joining me this week. Please follow me subscribe to the Ready Made Maths YouTube channel. Please follow me on Twitter, because on Twitter I'm going to be giving you information about any upcoming videos, and I'll also be putting the Dropbox link for this week's materials on there as well. Thanks very much for watching, and hope to see you next week for Mastery in Mathematics.